We wanted to find out how wall clouds form. It's a common question in meteorology. No one really knows for sure. So what we did was we took an old data set from Vortex 2 and we compiled it. We took reflectivity from it and we ran backwards trajectories to show exactly where these parcels are coming from. So then now that we know where the parcels are coming from, we're able to estimate cloud depth and cloud base. So using a technique called photogrammetry, we overlay a grid onto the wall cloud picture. So that with this grid we know the depth, we know the height, and with the backwards trajectories we're able to correlate the exact depth, the exact height with what we see in the picture.
So you have a lot of really, really fancy graphs. Can you explain a few of them to me,
Yeah,
what
sure.
they mean, what
Okay.
they're modeling?
Yep, so we should start off with the cloud photogrammetry. That's where it all begins. So once we overlay a grid onto the wall cloud, we're able to use basic trigonometry and find out exactly the height and the width, basically the spatial extent. So that's what this picture is. It shows us the height, the grids, and using this, we're able to approximate the wall cloud location. That's what this shaded area is. It's triangulated wall cloud location. So then once we know where the wall cloud is located, we're able to populate the wall cloud location with parcels. So that's what this picture shows here. So we populate the approximate wall cloud location and run backwards trajectories to see exactly where they're coming from. So now that we know where they're coming from, there's one more crucial ingredient that we need to know. It's what the low-level dynamics, what the low-level thermodynamics are, so that we can justify the lowering of the cloud base. So that's what this image shows here. Is we have low-level thermodynamics that we collected from the Vortex 2 data set, and using that in conjunction with backwards trajectories, we're able to justify the wall cloud lowering.
Okay. So how did you come across wanting to study this project? What was your motivation to start into wall cloud research?
Well, my motivation was my teacher, Dr. Atkins, had extra grant money, and we wanted to try something different, something brand new that no one's ever done before. So that's where it all started, and he just got new funding, so it's pretty new in the industry. It's pretty robust, and it's starting to take off.
Okay. So doing this type of research, what did you kind of learn about yourself and the type of research you want to do later in your life? Like, do you want to stick with more severe weather and modeling like this, or do you want to kind of branch out and do something different? Or
I found out this is exactly what I want to do. It's so much fun to just sit down and program. Not only do you program, but you actually get to work with the meteorology data. So it's like the best of both worlds for me.
Oh,
It's something I definitely want to continue in grad school.
That's great. So why is observations of wall cloud formation important to the meteorology field?
Sure. Well, as most people know, people associate wall clouds and tornadoes. So if we know more information about how wall clouds form, we're able to possibly justify formation of tornadoes.